Your wind energy, I'll repeat if you want me to repeat, I'll repeat after this. This is the last one I'll explain and then repeat wind energy. So elastic strain energy, it is energy stored in the object due to change in shape, size or length. So when the object changes shape, size or length, it will also store energy, and we call this energy as elastic strain energy. You can also say strain energy. So example, if you have a spring which is fixed from the bottom and you apply a force from the top, you try to compress this spring. So you try to compress this spring. So when you apply force from the top, what you will observe? You'll observe that the size of the spring reduced. The coils will come closer to each other compared to what was original. And if you release the force, the spring will return back to the same original position, length or size if it does not deform completely. So which form of energy is stored inside this spring? Because the spring size changes, the length changes. Originally it was longer, now it is shorter. Or opposite can happen. You have a spring and you add a load to the spring. So you apply a force. So when you apply the force, the spring stretches. So compared to the original size, the spring size increases. Both cases, here it is compressed. And here the second example, it is stretched or extend. So both cases there is a change in size. So whenever there is a change in size, change in shape, the energy stored in the object, and which form of energy stored in the object, that energy is called elastic strain energy. So energy in the object due to change in shape, size or length. Same thing, a sponge. So this is a sponge and you apply a force on this sponge. So you find it deformed. So you observe it is deformed, but when you release the force, again it will return back to the same original position. So which form of energy is stored in this compressed object? It will have elastic strain energy. So energy in the springs, energy in the strings or wires or sponge, they all have elastic strain energy. Due to change in length, shape or size, we call that elastic strain. Is it clear, the concept of elastic strain energy? When it deforms, it will have elastic strain energy. Deformation can be any deformation you stretched. If it deform permanently, you mean, Tausif, what you want to say? It's a permanent deformation or temporary deformation? If it deform permanently, then this elastic strain energy will convert into internal energy. So about the wind energy, So what happened? How a wind energy, a sun is providing heat energy to both. It's heating the part of the earth which is facing. That part absorbs the energy. So that part consists of sea and as well as land. But as you know, the size of a sea compared to the land is too much. Like only 30% of the land and majority 70% of is occupied by the water. So as the sun provides heat energy to both sea and land, land is not able to absorb too much energy because of small size and small capability to absorb heat. So there are air particles above the land and there are air particles above the sea. Sea, because of its greater volume and water is having a higher capability to absorb heat energy compared to other materials. So the air particles which are above the land will become hot more quickly as compared to air particles above the sea. So as these air particles above the land will become hot, when something become hot, it will move faster, they move away from each other. So the volume will increase. As the volume increase, its density will decrease. So density decrease, this group of molecules will rise up, because compared to air at room temperature, they have low density, so they will rise. So when these particles rise, the number of the particles in this region will decrease. So as the number of the particle in this region decreases, the air particles, because air is a gas, so gas is moving randomly. So these particles move from a region of higher concentration to a region of a lower concentration, and we have this movement is refers to wind energy. Is it clear? So the cold air, relatively cold air, will move from sea to the land, and we have a wind energy. Now we'll do some questions, the MCQs related to the topic I taught today. Yes, you have a question? You can use your mic, or if you want to use chat, that's also good. What's your question? The topic which we discussed today. Energy is released in some nuclear reactions. Some nuclear reaction take place in a nuclear power station, and some of them take place in the sun. Which one is nuclear power station and which one occur on the surface of the sun? Everyone should participate so that it will show your understanding of the topic. There are only two ways I can judge your understanding. One is during a class solving some questions, and another one by the test. So try to participate so I can identify that you are understanding a topic. So power station and nuclear fission and sun nuclear fusion. In next question, question number 2. A lorry of mass 4,000 kilogram is traveling with a speed of 4 meters per second. A car has a mass of 1,000 kilogram. The kinetic energy of the car is equals to kinetic energy of the lorry. What is the speed of the car? So they already gave you the answer that kinetic energy of a car is equals to kinetic energy of the lorry. So first you'll find the kinetic energy of the lorry or a truck. So kinetic energy is half mv square. So kinetic energy of the truck and kinetic energy of the car is same in the question. So we can say half mv square, the kinetic energy. The kinetic energy of a truck is 32,000. Okay. So kinetic energy of the truck, we after substituting the value, you got 32,000 meter per second. Sorry. Then kinetic energy of the car is half mv square. And they mentioned kinetic energy of the truck or the lorry is same as kinetic energy of the car. So this will be 32,000 equal to 0.5. M is a mass of the car, which is 1,000. And V is the speed at which the car is moving. We don't know, so that's V square. So 0.5 multiplied by 1,000, that's equal to 500. So 32,000 divided by 500 is V square, but we need a V. So 32 square root of 32,000 by 500. What's the answer? It's 8. Okay, so C is the right answer.
Sir, in the first question for
Yes.
the fusion and fission,
Yes.
sir, can you use fusion reactions to obtain energy, nuclear energy?
Can
We use fusion reactions to obtain nuclear energy.
we can use nuclear reaction, fusion reaction to obtain nuclear energy, but the thing is, a small scale can be done, like a small quantity of nuclear fuel which can undergo a nuclear fusion, you can obtain energy. But large scale is not possible. Why large scale is not possible? The issue is the confinement issue. Like you cannot trap that enormous amount of energy. Like if you, for example, if I make a nuclear fusion reactor means you are making a star, because stars are producing. So can you trap a star on the surface of the earth, or can you have any material which can withstand or hold this enormous amount of energy which is responsible for rise in temperature? So the issue is the confinement issue. That's why a small scale can be done, but for large scale it is not possible till now. Small scale fusion reactions are used, but large scale is not used. The nuclear nuclear fusion is having a greater potential to produce energy as compared to nuclear fission. But large scale is, the issue is the confinement. Question 3, what could be the answer? Work done is a product of force into distance. What's the answer for question 3? A, B, C, or D? Work done is a product of force multiplied by distance. So C is the right answer. A box of mass M slide down a slope of length L. The vertical distance is height is D against the frictional force F. Which row gives the loss in potential energy and the work done against the friction? Potential energy, you need height. So potential energy is mgh. M is a mass, G is a gravity, H is a height. In the question, the height is given D. So what is the potential energy? Potential energy will be mg D. But what about work done? Work done is a force into distance. So you should take against the friction. So this one is a force, and the distance which we move, the block move along the surface is L. So work done will be F into L. A is the right answer. Is it clear? Because potential energy is mgh. H is the height to which the object moves, or object lower the height, and work done, force multiplied by distance, the distance which we move along the surface, that is length. Question 5 is about efficiency. That we'll discuss later. There are more questions. We'll discuss later these questions. So next class, I will explain the changes in energy, energy transformation, and then numericals involved in change in energy. So I have another class actually, otherwise I will solve question 6 of it. I'll end the session and share the recording with you.